This video, I'm going to talk about how to learn embedded systems using the KuttyPy hardware. And this little board here, it's kind of similar to an Arduino, but there's a bunch of improvements to it. In the software, first you need to connect. It's going to ask you if the port is available. You may need to install drivers. Once that's connected, you have like a playground system here where you can tweak the state of each pin. For example, port P is connected to these red LEDs here, 8 of these. So PB0 to PB7 is connected to LEDs to toggle them. So let me make all these pins output types. So when I do that, the register DDRB, data direction register, now become all ones, that is 255. Now as I toggle these output pins, you can see that the LEDs are turning on at the same time on the board. And similarly, you can tweak all these pins. If they're in input mode, these will reflect the input state, whether they're high or low. Green is high. If they have special functions, for example, the PA pins have ADCs connected to them, 10-bit analog to digital converter. So if I switch this to ADC mode, this is the value of the ADC. And on PA0, I've connected this little LDR and it's internally pulled up. So as I change the light falling on the LDR, the ADC value will change. If you click on this label here, it will also plot it for you. So it opens up a data logger where you can set the amount of time you want to record for, the interval for recording. It's clear and start again. So you have a data logger and you can also download the raw CSV data. You can switch and view other ADC channels as well. Now, speaking of registers, there is a register playground here where, let's say I want to study what does tweaking the port register do. Let me write it to 0. So this is the write button and this is to read it back and show it here. So let me write it, just write it to 0. So all the LEDs are now off, the ones that were connected to B0. If I say 255, it means port B is all ones. And since one indicates an output high, when I write this, all these LEDs have turned on. And similarly, let's say I only want these 4 to light up, that's 240 in decimal units. Or if I, for example, if I write 15, that's the other 4, etc. So you can tweak registers, read and write them, and see how the hardware behaves. Now, it also has an I2C communication port. I've connected a BMP 180 pressure and temperature sensor to it. You just need to connect wires, supply, ground, SCL, and SDA. So those pins are here. It's marked as the I2C port. Right here, PC0 and PC1 are marked as SCL and SDA. So now here I can just say scan the I2C bus or any connected sensors, and it will automatically tell you which sensor is there. And since the communication protocols for more than 15 commonly available sensors are already baked into this, you can just click on this and start recording data. So pressure, and just look at temperature. It's plotting temperature. If I touch this sensor here, so you have like a quick and dirty data logger for a whole range of sensors: temperature, humidity, pressure, angular velocities, acceleration, all those common sensors that you can find in the market. And they barely cost anything. Like this one costs like I think 40-50 rupees for pressure and temperature both, and it's pretty good. You can also increase oversampling here. Okay, so that's the sensor data logger. Now, how do you program this port? So for programming, first you have visual programming. Now in visual programming, you have ports like this where you can drag and drop and attach blocks. So let's say, let me just throw this out. I want to make a data logger which reads data from this pressure sensor and plots it. So first I need a loop, repeat while true, just keep looping inside. And inside this, I want to plot y was time. Sensor block I'll attach here. Now I need to configure this block. Just click on the scan button and select the sensor. Set the parameter you want to read from that sensor, and that's it. You can maybe add a delay after this so it doesn't plot too fast, but it'll work. Now if I touch this thing here, so I've made my own data logger. Now you can introduce logical operators, mathematical operators, whatever you require to write code. Now, let's say I want to show this raw data on the screen. So I can go to in and out, print this thing, and under loops, I'll find this wait maybe 0.1 seconds. Okay. So this thing will now show the same data printed on the screen, 27 point these many degrees. Now, this requires a connected computer, right? It's continuously speaking to the hardware and executing tasks. But if you want to run this as a standalone unit running from a 5-volt supply, for example, okay, let's take a code where this microcontroller can run standalone. Let's say blinking an LED. There are a whole bunch of samples that are available. Let me pick out the blink sample here. I'll just click on that. So it is the data direction register first, and then inside a loop, just toggle port B. So that's blink. When you run this, this is in the connected mode. You can see the register being tweaked, and you can also see the LEDs going on and off. But this requires the laptop or phone to be connected to this. But it also generates the corresponding C code for this. In this C code, you can mouse over and there's a small help section at the bottom that tells you what each thing does. So DDR-B is data direction, port P is the output latch, etc. So it sort of explains those things, creates your C code. Now go to C compiler, compile and upload this code. So this step makes this independent of the computer. That user space code has been loaded. Now when you click on this run button, the computer basically detaches itself and allows the user space code to execute, which is basically blinking. Right? 1 second on, 1 second off. You can also use serial port data dumping. For example, in this case, print statement when you run it in the computer shows up on the screen. But for a microcontroller, it needs to output this data somehow. It does on the screen. So it will dump it to serial port. So in the C code, you can see that it has done all the initialization routines for the serial port. It has initialized the sensor interface I2C, initialized the sensor, and inside a loop, it's just dumping float values onto the serial port, which we will monitor. So in the C compiler, let me just compile and upload this 8 kilobytes of hex file. And once you do that, when you run this program, the serial monitor is running. It's telling you what is being received from the processor, and it's also plotting these things. So you can mouse over and see what are the values here. I can actually touch this and just heat it up. Be careful not to touch the communication pins. You get communication drops like that. But you get the general idea. We've not written any C code by ourselves. This is mostly aimed at students who don't know how to write C code yet. But the visual thing will write very self-explanatory code and generate it so that you can create standalone logic. So here you can have all sorts of things that you can build here and then implement it as a standalone mode if possible. Okay? So that's that. These samples have helped. Code is shown here. I missed out something. In the C compiler, you can change the font size here. You can change the theme. You can open and save your C code. Compile, upload, run, and back to visual. Here, of course, there are all these blocks and functions for KuttyPy stepper controller you can make. Plots are here. In the background thing, you have sensors which should program. That's the web page for it. It's essentially an embedded systems teaching tool where instead of renaming the pins of the microcontroller, those are preserved and they're labeled on the board itself. So we can read the data sheet and learn from binary registers, etc. It has all these features, programmed in Python, in C, and in Visual that you just saw. It's got a bunch of, you can use it as a simple test and measurement IO tool, just connect it to your laptop and have basic automation tasks running in the real world. These are the things that are already on it. A bunch of LEDs for port B and D. And there's an R2R DAC on C. A couple of switches, an RGB LED, a basic fuse, and that's it. There isn't much to it. All these sensors are supported on the software side of things. You can just plug and play without writing any code. You can plot information that's gathered from all these system supported sensors. Okay, so I think that covers the introduction to KuttyPy. Firmware version is 99. Okay, thank you.